Good morning, everyone. My name is Rudraksh Thameja, and this is my midterm research presentation for SIT 723 Research Techniques and Application at Deakin University. My research focuses on AI-based credit scoring, specifically benchmarking, machine learning, and deep learning models for credit risk prediction using the Lending Club and German credit datasets. The main issue I'm studying is whether AI can improve credit risk prediction in a way that is not only accurate but also explainable and suitable for responsible lending. The aim of my research is to develop and evaluate AI-based credit scoring models that improve default risk prediction while remaining robust and predictable. This problem is important because traditional credit scoring methods often struggle to capture complex relationships and borrower data. At the same time, modern lenders need models that are not just accurate but also stable and explainable. So this research focuses on balancing predictive performance, robustness, and predictability in a real credit risk setting. My literature review identified three important baseline studies. Number one is Chang 2002 used the Lending Club dataset and found the XGBoost and Lightbeat GBM performed strongly. Second one is Trivedi 2020 used the German credit dataset and showed strong results with the random forest and feature selection. Number third is Lisman in 2015 highlighted the need for a stronger benchmarking and better evaluation in credit scoring research. From these studies, I identified four key research gaps. First, limited cross-data set comparison. Second, class imbalance and robustness issues. Third, lack of sufficient explainability. And fourth, unclear evidence on whether deep learning really outperforms strongly machine learning models for tabular credit data. These gaps directly motivate my research. Slide number 4. Based on these gaps, my research is guided by three questions. First, how do deep learning models compare with strong machine learning baselines on the Lending Club at German datasets? Second, which pre-processing, feature selection, and class imbalance strategies improve robustness and minority class detection the most? How much interpretability can be retained through feature importance and SHAP-based explanation without significantly reducing predictive performance? Together, these questions aim to build a reproducible benchmark for credit scoring. To answer these questions, I am following a structured experimental workflow. I am using two dataset Lending Club, which is larger and more realistic, and German Credit, which is a standard benchmark dataset. The pre-processing stage includes data cleaning and coding categorical variables, scaling where required, and handling class imbalance. For models, I will compare logistic regression, random forest, XGBoost, Light GBM, and deep learning models such as multivariate perceptrons. For evaluation, I will go beyond accuracy and use ROC F1 score, precision, recall, and training time because minority class detection is very important in credit risk prediction. For explainability, I will use feature importance and SHAP-based analysis to understand model decisions. So far, the project has progressed well. I refined the topic from a broad automation-based idea into a focused credit scoring study. I completed the initial literature review and identified the main research gaps. I have also obtained both datasets, featured level exploration, and set up the Python-based experimentation environment for pre-processing and model development. At this stage, this project is on track and ready for the next phase of experimentation. For the current trimester, my plan is to complete the literature synthesis, finalize pre-processing pipeline, run baseline machine learning experiments. I've also identified keys which the large size of the Lending Club dataset will be managed through careful sampling, class imbalance will be addressed through weight and resampling, and explainability challenges will be handled using SHAP and feature importance methods. To conclude this project, to make four main contributions. First, it will provide a benchmark comparison of machine learning and deep learning model across two public credit datasets. Second, it will provide evidence and robustness, especially for class imbalance credit risk prediction. Third, it will provide interpretability for combining predictive modeling and explanation techniques. And finally, it will offer practical insights into when advanced AI models add value in lending and when a simpler assembled models may still be better. Overall, the project is well scoped, research driven, and on track for the strong outcomes. Thank you so much.